Welcome to The Explainer. Today, we're unpacking something absolutely fascinating about artificial intelligence. We're going to look at the surprising, kind of hidden truth about how AI actually processes really long documents. If you've ever fed a massive PDF or a huge report into an AI and been totally amazed by how quickly it answers your questions, you'd probably just assume it knows the document the same way you or I would after reading it. But as we'll see, the reality of AI memory right now is surprisingly inefficient, completely fascinating, and honestly, on the verge of a massive breakthrough.
Okay, let's dive into this bizarre inefficiency. When you give a modern AI model a long document and ask it a question, it doesn't just pull an answer from some settled permanent memory. Instead, in a very quiet and incredibly expensive way, it is essentially rereading everything it has seen so far just to produce the next single word. It's not reading the whole text completely from scratch, but mathematically, it's doing something very close to it in spirit. It's a huge bottleneck. To understand why it does this, and more importantly, how we're going to stop it, we really have to look at how AI takes notes.
So let's move right into Section 1, the AI notebook problem. Imagine you're reading a massive 1,000-page book, and for every single new word you write in your notes, you force yourself to read all your previous notes first. By page 900, you are manually scanning a literal mountain of notes just to write down one more word. That growing, wasted mountain of effort has a technical name inside an AI model: the KV cache. The KV cache is basically the model's working memory of everything it has read up to that exact moment. Every time the AI reads a word or generates a word, it adds to this cache. It's the anchor of its context. But because the AI stubbornly refuses to forget anything, this cache becomes an absolute beast. Tens of gigabytes. For a large AI model holding a book-length context, the KV cache can easily swell to this massive size. It's the digital equivalent of carrying around a hoarder's backpack. That is, tens of gigabytes of working, active memory required just to hold a conversation about a long text. It is way larger than the model naturally wants to carry. And remember, it just grows heavier and heavier with every single token, every single word that gets processed. Which leads us to this incredibly frustrating, wasteful cycle. Step 1. The AI carries this giant, tens of gigabytes pile of memory that is mostly irrelevant at any given millisecond. Step 2. You step away from the chat to grab a coffee, the system times out, and it simply throws that entire mountain of notes in the trash just to save server space. Step 3. You come back, ask a simple follow-up question, and the AI has to secretly read your entire document again from the very beginning to rebuild that KV cache before it can say a single word. We are currently paying a massive, grinding computational price twice. Once to carry the bloated memory, and again to endlessly rebuild it. There just has to be a better way.
That brings us to Section 2, how your brain works.
To find that better way, we actually need to look in the mirror, because the ultimate solution is already running perfectly inside your own head. Think about it. You read a 1,000-page novel last year. Do you remember every single sentence? Well, of course you don't. You remember the shape of it. You remember the main characters, the key plot turns that really mattered, maybe a handful of incredibly vivid scenes. Everything else, the transition sentences, the minor descriptions, the background dialogue, it's all softened into a blur. And the real magic of human cognition is that you function perfectly well like that. You can discuss the book over dinner, recommend it to a friend, or passionately argue about its ending. You naturally compressed 1,000 pages into a manageable mental sketch, and you lost almost nothing you actually needed.
Let's look at how we apply this in Section 3, blur instead of delete. And this brilliantly illustrates exactly why blurring is the answer. If an AI's working memory is full of both vital and useless notes, why keep them all at full size? The trick researchers are figuring out is how to let the quiet notes gracefully fade. There are basically two ways to do this. The first is deleting. Deleting is final. If you delete notes about a minor character to save space, and it turns out that character is the murderer in the final chapter, the note is gone, and the AI is stuck. It's like a torn photograph. The second way is blurring. Blurring is much gentler. You mathematically fold a handful of minor notes together into one fuzzy, compressed summary note. The exact detail is softened, sure, but it isn't annihilated. It's like a smudged photograph. If that minor detail turns out to matter later, you at least have a faint trace and you know exactly where to look. Blurring beats deleting almost every single time.
Now I know what you're thinking. It's a completely honest objection. What if you blur away the one specific detail someone later asks the AI about? If the memory is smudged, doesn't the AI just fail? The honest answer is yes. Occasionally, you will blur away something you end up needing. But actually, that is the point of the system, not a flaw.
Because what do you do when a friend asks you a hyper-specific detail about a book that you've forgotten? You don't panic. Your brain doesn't crash. You just go back and look it up. You pull the book off the shelf and reread that one specific chapter. Well, an AI can do the exact same thing, and far more gracefully. Most of your questions will land on the parts of the memory it kept sharp, and those get answered instantly. But for that rare question that needs a blurred-away detail, the AI simply triggers a fallback. It uses a search tool, or it rereads just that specific section of the document. You only pay the expensive computational cost at the rare moment it's actually needed.
This brings us to Section 4, the art of escalation.
Now, what's really interesting about this slide is that if we zoom out from AI for a second, we realize this blur and lookup trick isn't just some clever hack. It's literally a universal law and successful technology. Look at zip files. They compress your documents enormously because real text is full of predictable structures. Only the truly rare, random parts resist compression. Look at internet servers. The whole internet runs smoothly because servers assume agreement most of the time. They only escalate to complex, grinding resolution protocols when rare conflicts occur. And now AI memory. The smart move is always the exact same. Assume the world is mostly smooth. Handle the easy majority cheaply by keeping just the main note sharp, and escalate to a complex search only for the rare, blurred details.
Yet most of AI today does the exact opposite. It totally ignores the art of escalation. It pays the absolute maximum cost everywhere on every single word, constantly carrying around tens of gigabytes of perfect memory, just in case. That is the grinding wastefulness that researchers are trying to fix right now with this blurring technique.
Let's look at the payoff in Section 5, saving to the shelf.
There is a massive secondary payoff that happens once we successfully compress this memory. It's not just about saving processing power, it's about fundamentally changing how we interact with AI. Imagine this scenario. If you can compress an AI's reading session, that giant KV cache, down to a small enough size, you don't have to throw it in the trash when the chat times out. Picture saving your heavily annotated 1,000-page book to a digital shelf. Next week, you can pull it right back down and pick up exactly where you left off, in mere seconds, without forcing the AI to start reading from page 1 all over again.
The math on this finally flips, and that is absolutely crucial. If you try to save a massive, uncompressed memory, it's actually a bad trade. It costs a fortune in server storage, so companies just delete it and rebuild it later. But a compressed, strategically blurred memory, that becomes incredibly cheap to keep on a shelf. It reloads in seconds. For any long-running project you're working on, a stored, faithful memory stops being an impossible luxury and actually becomes the core feature that makes the tool usable in the first place.
Finally, let's explore Section 6, the unsolved memory frontier.
So the crucial point is that everything we've discussed so far, the keeping, the blurring, the storing, is already being chipped away at by researchers. Some of it is running in real systems today. But there is one fascinating hurdle left to overcome: the problem of shifting intentions. Think about it. Your notes from reading a novel for pleasure, focusing on the romance, the sweeping landscapes, are completely different from the notes you take to pass a strict law exam on that same book. The unsolved problem in AI is what happens when you compress and freeze a memory under one set of intentions, and then pull it off the shelf weeks later, asking questions with a completely different intention. And this is exactly why the blur, don't delete instinct is the only way forward. If the AI simply deleted the boring legal details because you were initially reading for pleasure, those details are annihilated. When you come back for the law exam, the AI is totally useless. But a blurred memory can still be squinted at from a new angle. The legal details were softened, yes, but a faint trace remains. The AI knows where to escalate, where to search, and where to reread to fulfill your brand new intention.
I want to bring all of this together with a quote from the source material by Greg that absolutely perfectly encapsulates everything we've learned in this explainer today. AI doesn't need a perfect, infinitely expensive memory. It needs a good sketch, a cheap shelf to keep the sketch on, and the good sense to go look something up on the rare occasion the sketch isn't enough. It really is that beautifully simple. We are moving from brute force, wasteful computing to a system that is cheaper, faster, and remarkably similar to the way you already think.
Which leaves us with this final thought to ponder. If AI memory architecture is evolving right now to become a compressed, blurred sketch stored on a shelf, exactly like human memory, what is going to happen when these vast intelligences start pulling down old memories and squinting at them from entirely new, unpredictable angles? The way we interact with machines is about to change forever. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll see you next time.